Hello there and welcome back. This is going to be part one of the two parts series I'm going to make about a very interesting project I had been working on, and I think it's a lot of fun and most of you will like the idea. So not so recently I have been working on some validation and other stuff for the company I currently employed at, and I have found this cool module in Python called testinfra. This is able to provide you with a very easy way to write unit tests which are able to tell you many information about these devices and you can compare them what you see to the ones what you expect. So basically you can provide a platform for validation. And there was a class in this module which is called socket, and the socket class has two properties and one function. And basically my idea was that I should be able to write a Python module with a few classes that is able to draw some kind of topology from this information. My idea was that in order to do this, I need a way to discover these devices and how they communicate with each other. So basically, if I have this device and I get these listening sockets, I can see that on TCP protocol, on every interface available, it is listening on the port 22. And this is also true for IPv4 and IPv6. And it has some Unix sockets and so on. And if I have this information, I can say that I want to know every single client that is connected to that socket. So basically, I have this information which tells me on which port, on which protocol, which servers are in communication with the node I'm looking at. And you know, on most of these topology visualization tools, all you have to do is specify that you have this node, this node, this node. They have coordinates, and afterwards you specify the links. And basically a simple link definition goes like this. You go from this node to this node, and that's it. And you have a unique ID for the link. So, but this is just a small nuance. So I got the idea that with this I should be able to write the script I want, and on the first part I'm going to show you how you can write the support classes, and on the second part I'm going to show you a demo how you can actually use it. So let's get to it. Yeah, this is the best game ever made. So this is the do I get this right? This is going to be our mapper class. For this to be used, we are going to import the socket and testinfra module, and we will call this class the mapper, which will inherit from the object-based class, and it is going to have a real name, connection, filtering. Based on the testinfra definition, you can filter for many information from the get listening sockets output. What I need is only the TCP. So this is basically just a filter from the perspective how I see the problem and the resolution for this. But I tried to generalize this class. So this T and U means the TCP and UDP. So afterwards we have this TCP, this UDP, and finally the Unix socket. And we will also have this socket info, which is going to be none. We also have this port mapping, which is also none. So we should initialize this class, and all we need to do to initialize this class is specify the host and the username. In order to use the test infra module, you need to choose a protocol for getting the data you want. And let's say username, and connection is going to be the test infra.getHost with the Paramico protocol, and this is going to be your username at host. And we will format it with the self, with username, and the self.host. And we are going to try to resolve a real name for the device, because it should not matter if you specify an IP address or an alias or the actual host name. We would like to know this information regardless. So the self host and the first item in this. But let me show you what this actually does. So I start Python, I import the socket module, and I say that socket.getHost by address, and I have a Raspberry Pi on the network. So it's called PF server, like file server, and the first item in this list is going to be the name of this server. So this is all this line does, and we are going to need this socket get host by name that host. What it does, it is going to give us the information about the IP address of that device. It is going to be important because we only want to check those connections that are not for the local host, because there can be devices or applications which communicate with these TCP or Unix sockets, and they have the same IP address. So yeah, import socket get host by name, and yeah, this is the other. And yeah, what I would like to do, I would like to override the stir method and just return that this is how our class looks like at the moment. Name self.host self.username, and we are going to define a property which is the sock info, and we will return the self.socketinfo. We will also have a property which is the client info, which will return the self.port mapping. We also need this real name and the IP address. So real name, IP address. What we return is the real name and the IP address. And this is where the fun begins. So we will have this get listening sockets, and this needs the self and the filtering as arguments. And we say if the filtering is none, then we will raise an exception which says that you need to specify a filter. On the other hand, if the filter was specified but not in the filtering methods which are known how to process, then also an exception is raised. Invalid filtering specified. Valid filters are let's be a nice citizen and let them know which filtering is invalid and which are the valid filters. So filtering, and we would like to join by comma the array of the self.filtering. And yeah, what we will try is to get the socket info and if it fails, then we will raise an exception that we could not initialize testing from connection to the host from none. All right. If the filtering that was specified is the raw filter, then we will say that the socket info equals to socket info, and if filtering is the T and U, then we will initialize our socket info with the TCP array and a UDP array. Damn. And we say that for every item in the socket info, if the TCP in the item or the UDP in item, then the root that we want to append to is the TCP in our dictionary, as the root we want to append to is the UDP. And we will prep the item by splitting it by the protocol separator, and this prep value is going to be the first, which means that we will either have the IP address or the triple colons and the port. So if we have 3 of these characters in the prep, this means that we are listening on all IP addresses, and the port is the prep replace 3 of these with nothing, so whatever is left is the actual port at the end. Else we will have the IP by splitting the prep by the colon and getting the first of the new array, and we will have the port by splitting it this way and getting the first item in the array. And what we would like to do after we have the IP and the port is to update or append to the appropriate root of the socket info these two informations. So the first one is the IP, and the second one, you may guess, the port. And basically this is how I imagined processing the TCP and UDP information. And the other situation is when we have the filtering specified as TCP or the filtering specified as UDP. So if we have this TCP filtering, then our root equals to TCP, and otherwise our root equals to UDP. And the self.socket info is going to be equal to the root as key and the empty array or list as a value. And after that, we will say that for every item in the socket info, not root in item, then we continue. This means that if we are looking for TCP, then at the output of the testing function, we will skip every line that does not contain the TCP. So all that we are left with is the TCP. And we will prepare this item by splitting it and getting the first element. So we know that everything we will have afterwards this is going to belong to the TCP root. And if the three of these signs are in prep, then the IP is the same as before, so we are listening on every interface's every IP address, and the port equals to prep that replace the triple colon with nothing. Otherwise, we say that the IP is the prep.split and the first item, the port is the prep.split second item, and in the end all that is left is to update this one. So we will append this information to the specified root. So I think it could be reworked to work or function a little bit differently, but so far it seems to be fine. And yeah, if filtering equals Unix, then what we will do is socket info Unix, and for every item in the socket info, if the Unix is in the item, then we will say that the socket info's Unix root should be appended with the item that's split by the Unix and the first. And all that is left is to return the self.socket info. This is how we get basically the information we need from these listening sockets. And what is left is to get the clients. And we will have the skip localhost as by default true and optional argument. And we will have a skip IP, which will provide us a way to exclude specific endpoints or connections from the data we want to work with. It can come in handy because when you are using this class to pull information, you will see that your device from which you run the script is also present in the topology in a way that you will see that it uses the 20-second port, so it goes with SSH. And if you want to, let's say, exclude the IP based on the IP address of your device, this is a very easy way to do it. So what we will do, we will need to fill the socket info with the self.get listening sockets based on filtering of TCP, and the port mapping should be initialized also. And I say that for every connection in the socket info, and the TCP route. I say that if there is no port present, so the data we got is somehow malformed. I think the reason for this could be because when you issue the get listening sockets, you get an array with the protocol, the IP, and the port. And when you use the clients to get the actual information, it is possible that that list you are working with originally is not valid anymore, because the connection that was established at the time you queried the table is already disconnected. So you will not find any clients to that data you are working with at the moment. So if this connection is not not present anymore, then it should be just simply skipped. So we will go around in every client and say that we want to get the TCP plus connection the clients. So basically what it does is it will get this data that the server had connections on the port 80, because let's say it's a web server, and it will query every client that is communicating through this port with the server, and it will be a list or an array of clients. And yeah, what we will do is, if the client's first item, which is going to be an IP address, is equal to 127.0.0.1 and skip localhost, then we will just simply let it go and continue. So this way, if I specified in the argument that I want to skip localhost, then it will check these and they will both become true, and the rest of the for loop will be just skipped and go to the next item. And yeah, we will also have this option where the server.ip address equal to the client. So by default we will skip the interface where we have the connections originating from and to the same IP address. So basically the service communicating via the local hosts between processes. So that is just going to be continued, and if not, skip IP is not, then if the client's IP address equals to the skip IP, then we will continue. So basically this processes this argument. So if you specify an IP, then this will not be none, and if the IP address or whatever is specified matches the client's first item, then we will just skip the rest of the loop. And yeah, this is where the fun begins. So if we do not already have the connection port in the dictionary, then we will just simply update our dictionary with the connection port and a nice array, and Yeah, I recalled strange. I thought it was a bug, but basically it was my lack of understanding. So we say that if this connection port key doesn't have a value of client IP, then this connection port should be updated with the client. So, this is okay, and this is the client 0 with the array. And in the end, all that is left is to update this with the gathered information. So client 1. Basically what we will get afterwards is that a dictionary where you have the first set of keys as, let's say, port 22, and it will have a dictionary where it has this IP of whatever dot whatever, and it will have a list of ports. And you will have multiple of these. Yeah, so this is how this data structure will look like. And in the end, all that is left is to return the servlet's port mapping. Cool. So basically, this was the first part. I know it was long, but I hope you liked it. If you did, stay tuned for the part 2, in which I'm going to show you how you can visualize this information. Thank you for watching.